As an Ansys partner since 1984, we are highly committed to helping you design, simulate, and succeed.
Hello everyone, this is Alex Austin, Structural Group Lead for DRD Technology. This application example for fracture mechanics in Ansys covers fatigue fracture of a splined gear carrier. The objective of this simulation is to simulate fatigue crack growth of this splined gear carrier, determine the number of cycles for the crack to grow into the spline. This is a bit more complicated geometry where we have a spline carrier with 3 legs. You can see these yellow faces here. These are bearing surfaces at the end of these legs. We have a spline shaft sitting into this carrier where we have a torque applied to this red face here. And then the bearing surfaces are held in place but free to rotate around their y-axes. We have a crack situated in this little corner down here where this orange arrow points. You kind of see the little surface right there where the crack is. So the crack is very small starting out with respect to the overall size of the structure. Now again, Ansys simulates crack growth through a couple different means here. Ansys will calculate the far field stresses around the crack, determine the direction of crack growth, so we can have general 3D crack growth that is not planar. And then, of course, Ansys will calculate the stress intensity factor from the far field stresses and the angle at which the crack grows. We can have general 3D crack growth, so we can have mixed mode loading that will lead to mixed mode crack growth. So the crack can grow off plane at an angle and so forth. What that ends up looking like is if we start with a structure with a crack on the left, it will grow to the right, and this is just growing straight to the right in this instance. But as the simulation continues, Ansys will calculate the fracture parameters, determine the number of cycles, and then crack the structure one element and continue that calculation for as many times as you tell the software to. And then what that generally leads to, as the crack grows from left to right in this graphic, remeshing occurs over the course of the simulation to account for that now cracked structure. This all happens automatically at the solver level. The user doesn't have to do anything. Now what that looks like in this example is, we can very simply input just this center region here to account for just the typical linear line on a log-log plot of crack growth rate versus stress intensity factor. However, we can also input this entire curve that represents very slow growth, that linear region I just mentioned, as well as rapid unstable growth where we reach the critical fracture toughness of the material. We can take the material data, typically pulled from material testing, and input that into Ansys directly. And so in our particular case, we take the fatigue crack growth rate curve for 4140 House-tempered steel and input that just as a set of XY data points into the simulation, and Ansys will follow this curve depending on what the calculated delta K is to determine what the crack growth rate is. So for example, if the calculated stress intensity factor range is 10 megapascal root meters, then we can go up to this curve, this blue set of data points here, and then over to the left, and that would be the crack growth rate, and Ansys would calculate the number of cycles from that. So Ansys will do that throughout the entire simulation. Every single node that exists on the crack front, it'll calculate the number of cycles. What that ends up looking like is if we start with a crack down here at the kind of corner of this leg, it will slowly grow up and around into the spline at the top. Now in this particular instance, the stress intensity factor does not drop below the threshold value or the minimum data point on that previous crack growth rate curve. It continues to grow and grow, and in this instance the simulation just simply stops because we've not told it to solve any further. Though it is definitely possible to grow the crack all the way through the splines, or in the case of crack arrestment, the crack could stop growing. Interesting thing about this particular example is that if we look at the reaction forces at the three bearing surfaces on those legs, we can see that as the crack grows, starting in this corner here of this kind of lower left-hand leg, that the load that is carried by that leg gradually decreases over the course of the simulation as the number of fatigue cycles pile up, and then the other two legs have to carry that load and react to that overall torque that's applied through the spline shaft. So we can account for the changing stiffness as the structure continues to break and crack open. For more information on fracture mechanics in Ansys, we have a couple webinars that you can view on our website at drd.com/resources. We also have a fracture mechanics training course that you can find information about the content as well as schedule on our website, drd.com/training.
Contact us today to discuss your unique physics challenges and find the right Ansys tools for you.